Hello guys, how are you? In our lesson today, we're gonna continue talking about dot structure or Lewis structure. As we said before, we used dot structure to represent the valence electrons for each atom. In this lesson, we're gonna continue using electron dot notation as compounds. Before we starting with our examples, we have to know that it is also called Lewis structure, which is formula in which atomic symbols represent the nuclei and inertial electrons, which means the symbol itself, like hydrogen or fluorine or chlorine or any symbol for any atom, represent the nuclei itself and the inertial electrons. This is why we don't write the inertial electrons in our configuration. While dot pairs or dashes between two atomic symbols represent electron pairs in covalent bond, which means that we are using only the outer shell electrons or the valence electrons to represent the covalent bond. And each two electrons, as said before, will form one bond. After that, we will have the structural formula, which is a formula indicates the kind, number, arrangement, and bonds, but not the unshared pair of the atoms in the molecules. So when we draw the structural formula, we just remove the unshared electrons and keep only the bonds between atoms. And we're going to repeat this point again in this lesson or the next lesson, inshallah. As a start, we have to know that each bond is made of two electrons. So when we draw carbon with hydrogen, that means that here we have two electrons in this bond, one from carbon and the other one from hydrogen, sharing H with O. That means that here we have two electrons. Another H here, it means that we have here two electrons. For example, for C, H. For we have C, H, 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 which means we have two electrons at each bond. So the total electrons around carbon is 8 electrons, which is the octet rule. Now, we draw before C, H, 4, and C, H, 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 H. Now this formula is called molecular formula, as explained in the previous lesson. And here, this one is called structural formula. Now here, as you can see, we have the number of atoms, which is 5 atoms, and we have, or we can see, the kind of atoms that for H and 1 carbon. So far, we are just like the molecular formula here. We can see the number of atoms, we can count it here, 5, and the type of atoms, which are 4 hydrogen and 1 carbon. So far, both formulas are the same. But in the structural formula, we can see the arrangement of atoms and how they are combined to each other with the types of bonds inside. So here we can see single bond, single bond, single bond, single bond. And we can see that the 4 hydrogen atoms are arranged around the carbon atom, while we can't see these points here in the molecular formula. So this is the difference between structural and molecular formula. So here we have the arrangement of atoms and the bonds inside the compound, which we can see at the molecular formula. So how can we draw the structural formula for the compound by using Lewis structure? We have an example here. Draw Lewis structure for iodomethane, CH3I. The first step, and here you have to follow the steps as it is. First step, determine the type and number of atoms in the molecule. The formula shows 1 carbon atom, 1 iodine atom, and 3 hydrogen atoms. Second point, write the electron dot notation or the dot structure for each of atoms. So carbon, remember that here we are counting only the valence electrons. So carbon contains 4 valence electrons, and iodine contains 7 valence electrons, while hydrogen contains only 1 valence electron. So these are the atoms with the dot notation that we're going to use in our compound. Third step, determine the total number of valence electrons available in the atoms to be combined. So we have 4 electrons from carbon, and we have 7 electrons from iodine, and we have 3 hydrogen atoms with 1 electron for each. So 3 atoms times 1 electrons equal 3 electrons. The total is 14 electrons. Now we have to arrange the atoms for the skeleton structure or the structural formula. If carbon is present, it always will be the central atom. Remember, carbon, if we have carbon, it will be always in the center, and we're going to arrange all the other atoms around carbon. Otherwise, if we don't have carbon, we look at the least electronegative atom and put it as a central atom, except for hydrogen, of course, because hydrogen is never central. Then connect atoms by electron pair dot. We draw carbon in the center, then we arrange the other atoms, around carbon, and put 2 electrons in each side to form the bond. So now here we have 4 bonds with 8 electrons. Remember that we have 14 electrons here, and we already took from the 14 electrons, we took 8 electrons. So we still have 6 electrons. Now we add unshared pairs of electrons to each non-metal atom except hydrogen also, such that each is surrounded by 8 electrons. So how? Now here we have iodine. Iodine already contains 2 electrons with carbon, so iodine needs 6 electrons to reach the octet rule. So we add the 6 electrons around iodine, and now the total number of electrons used is 6 in iodine plus 8 here, so the total is 14, which is the same of the total number of electrons we have. Count the electrons in the structure to be sure that the number of valence electrons used equal to the number of the valence electrons that available for us. And that's it. Another example. Okay, here, this is a homework for you. Practice question. And also it is mentioned in the weekly plan, page 176. Let's take another example. For example, H2O. We have oxygen with 6 electrons and hydrogen 1 electron, but we have 2 hydrogen atoms, so times 2 equals 2 electrons, and here we have 6 electrons. The total is 8 electrons. Now we use O as a central atom, then we arrange H, and form electrons here around. So here we have 2 electrons and 2 electrons, so the total is 4 electrons. So here 8 electrons minus 4 electrons, we still have 4 electrons. We rearrange the 4 electrons around oxygen like this. So this is the skeleton structure for H2O, and we can redraw it this way. O, H, H. This is the structural formula. And we don't write the unshared electron here. Now what we mean by unshared electron? This is O, and H. Now here, remember that we have 2 electrons in each bond. These 2 electrons, because they are sharing electrons or bonded electrons, we call them shared electrons or bonded electrons. While, what about these 2 electrons? They are just located without doing anything around oxygen. They are inside oxygen orbitals only. So, because they are not forming any type of bonds, we call them unshared electrons. We have 2 pairs of unshared electrons. This is the first one, and this is the second one. So we have 2 pairs of unshared electrons. Another example, what if we are talking about N? Same thing, N contains 5 electrons and H contains 1 times 3, which is 3. So the total number of electrons used is 8 electrons. Now, nitrogen will be the central. Okay. Now we have to distribute hydrogen around nitrogen. And of course, we are not talking about the shapes actually, how they are in the 3 dimension. There's something else we're going to talk about it later. So we have 2, 2, 2, so 6 electrons used. Still means that we still have 2 electrons. So just add 2 electrons to nitrogen here to have NH3. Now nitrogen is fit with the octet rule, 2, 4, 6, 8 electrons. Another example. What if we are talking about SO3 minus 2? What is the situation here? We have S with 6 valence electrons, and we have oxygen with 6 valence electrons times 3, which is 18. And we have also minus 2 electrons, which means that we have another 2 electrons, because this minus 2 means that we have 2 electrons added to this compound, so we have to count them here. So the total number of electrons we have is 26 electrons. Now, which atom is the lowest electronegativity? Of course, as you know, as we're going down within the periodic table, electronegativity will be decreased. So sulfur, located in the same group as oxygen family, but it is below oxygen. So sulfur will be the central atom, the less electronegativity. Then we draw O, O, O. And remember that sulfur one, two, three, four, 5, 6, and oxygen also is the same. 1, 2, 3, 4, 5, 6. So first of all, put 2 electrons here. So 6 electrons minus, we still have 20 electrons. Now complete the electrons for the non-central atoms to make sure that each of them fit the octet rule. So we add 6 electrons to oxygen here, and 6 here, and 6 here. So 6 times 3, we used 18 electrons. So we still have 2 electrons left. We add them to sulfur. So all atoms now are suited with the octet rule. So it will be S, O, O, O. With, of course, don't forget to write the minus 2 here over the compound to show that this compound contains an extra 2 electrons inside. Hope that you get it, guys. So we have SO3, NH3, H2O, and the first example from the book, CH4. Now, in our next lesson, we're going to study other cases of Lewis structure. So I hope that you don't be think about exceptions. We're going to talk about it later. Thank you and be safe.